Welcome to Train Signal. You're watching a video all about routing. In this video, I'm going to explain what a router is, and we'll take a look at how to set up Microsoft Windows Server 2008 as a router. I'll talk about the difference between static and dynamic routing, take a quick look at a couple of the dynamic routing protocols, and then show you how to set up one of these protocols in Windows Server 2008. So, what exactly is a router? Well, as you can see here, a router is a device that forwards data packets along networks. A router is connected to at least two blah 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 blah. Yeah, this is the type of lengthy explanation you would get if you tried looking up the actual definition. Let me see if I can simplify this for you. See, a router is really nothing more than a device that allows communication between different networks. A host, or we could just simply say computer, like I have one little computer right here, only knows how to communicate with other hosts or computers on the same network. If this computer wants to communicate with a computer on a different network, it can only do so through the use of a router. Now, I've illustrated a few different examples of where routers are commonly used here. The first example I have here is really a simple network that's been divided into two network segments. This is common in many office environments where there's just too many computers to efficiently communicate on a single network. So when you divide into two or more network segments, you have to implement a router to allow communication between them. Another example I have here is where we have our office network and the internet network. Now that's two different networks, where we use a router to allow communication between them. We have the same situation at home, where we have our home network and the internet network, and again we have a router, but this time you'll notice very often they're referred to as cable modem routers or DSL routers. This is basically to simplify things for the average home user. The average home user who does not know a whole lot about technology knows that they have cable modem connectivity or DSL connectivity to the internet, so we label this router as a cable modem router or DSL router so they understand what they're buying, or at least understand that what they buy will get them out to the internet. Now, the last example we have here is where we have two different offices that need to communicate with one another. Now, there's really two versions of this example. One version is where I could draw a little cloud in here and call that the internet. This is probably the more common example in today's environments, where both offices are connected to each other through something called a VPN, or a virtual private network. Now, don't worry a whole lot about VPNs and how to set them up. We'll cover that in another video. But for right now, just to understand how we would use routers, each office would have their own router to get to the internet to facilitate this VPN connectivity. Now, a VPN is not always used. In some instances, you will have a dedicated line, sometimes referred to as a T1 or a T3 line, between the two offices. In that set of circumstances, you would still have a router in each office to get connectivity to that T1 or T3 line to allow communication between the offices. All right, let me clear that out, and let's take a look at maybe a more typical office environment. Here we have our main office. And in our main office, it's a large network, and so it's been divided into many network segments. And here we have routers that have been put in place to separate connectivity between these network segments. Now, this last router that I circled here, you'll notice has more roles than just separating off to a different network segment. We also give connectivity to the internet, as well as connectivity with another router to a branch office. So one single router can serve many roles. So in this main office, we have a router to give connectivity to the internet and over to this branch office. Now, this branch office also has a router of its own to give connectivity directly to the internet. Now, this is done if this branch office was large enough to warrant direct internet connectivity. If it was a smaller office, then we may just get rid of this router here and use the main office to give connectivity out to the internet. We see both out there in the real world. Here we have another branch office with another router giving connectivity to the internet. Now, this time this branch office will only use the internet to gain connectivity with the main office. And then over here we have our home users. Again, not that unusual in today's corporate world. Many companies will have something called telecommuters, which is where we have people who work from home but need to be able to connect in with the office network. Or sometimes you even have somebody who is just out on an isolated task where they need to be away from the office. And in those environments, again, a router is used to gain access to the internet so that this home user could then get to the main office or really to either one of these branch offices. Whew, that's a mess. Let's clear that out of there. This is what a very typical corporate network would look like, with main offices, branch offices, and remote users. So let's take a look at the global Mantix network and see where we need some routers. Let's take a look at each city one at a time and see where routers are needed. Starting off with New York. In New York, I see the need for one router for the comlink to the Tokyo office. We have a router needed here for connection to the internet, and a third router needed here for the comlink to the Chicago office. So it looks like from this drawing in New York, we're going to need 3 routers. But I'm not sure that's all we need. See, New York has a lot of computers. And when you have a lot of computers, you're probably going to want to divide down into multiple network segments. Once you've divided your network into multiple network segments, you need to implement more routers to allow communication between those network segments. So I'm going to say 3 or more routers needed in New York. Let's move down here to Tokyo. In Tokyo, I see the need for one router for the comlink to New York and another router for connectivity to the internet. So it looks like in Tokyo we need 2 routers. Now, again, do we need more? Well, we've got 50 plus computers going on in Tokyo. You could go both ways with this. 50 computers really do have the ability to communicate efficiently on a single network segment, but I would need to know more about the actual layout, the physical layout of where those computers are to decide if we're going to need more networks or not. So we're going to say 2 and maybe more. And then let's take a look over here at Dallas. In Dallas, well, we have one communication link to Chicago. We only have just a few computers, so I'm going to just simply say 1 router is needed in Dallas. And then let's wrap this up by looking at Chicago. Chicago, I see 1 comlink to New York, 1 comlink to Dallas, and 1 connectivity to the internet, or 3 routers needed. Now again, we're approaching almost 100 computers. Might have a need, so again, maybe another router to divide that. You might divide that into a second or possibly even 3 network segments. We're not really sure. Again, have to know the physical layout. But there is one more thing that we have with the Chicago network that doesn't pertain to the other offices. You may recall from the original explanation of the Global Mantix network that we have, I'm going to draw a little picture here. I'm a wonderful artist. I know you've learned that already. This is a picture of a house. The reason I drew a picture of a house is because the Chicago office has 5 telecommuters. Those are employees who work from their homes. Now each of those 5 telecommuters are going to need a router in their home to give connectivity to the internet so that they can connect in with the Chicago office. So in the Global Mantix network, the way we know it right now, it looks like we have a need for 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 routers, and that's just for the communication links between the offices, and then we're going to need additional routers anywhere we have a breakout of network segments within a given office. All right, well, let me show you how Windows Server 2008 can be used as one or more of these routers in the Global Mantix network. Alright, I'm going to go ahead and connect to New York Member 1, a Server 2008 computer. There we go. And the first thing we need to do if we want to turn this machine into a router is we have to add a role. And in order to add a role, we're going to click on Start and then select Server Manager. In the Server Manager, I'm going to click on Roles. And before I go and add a role, I want to point out that I have no other roles installed right now. It is possible, as a matter of fact, it's quite common to have a router also hold other roles. For the sake of learning this, If you were following along in any other videos and you had already installed roles, I would recommend that you uninstall all those roles to have this machine just be a router until you get comfortable with it. So I'm going to go ahead and click on Add Roles. Again, you'll notice none of the boxes are checked. And I'm going to click on this one right here that says Network Policy and Access Services. And then I'm going to click Next. It gives you an introduction to the Network Policy and Access Services. Click Next again. Now, this is where I want you to realize that there's more than one thing we can do with these services. The Network Policy Server itself, we'll talk about in another video. For right now, we're simply going to select Routing and Remote Access Services so as to allow ourselves to become a router or do routing. So I'm going to click on Next. It gives me a quick little update of what we're going to do. I'm going to click on Install. And it begins the installation process. Now this will take just a moment, so I'm going to go ahead and pause the video and I'll be right back with you when it's done installing. Okay, here we are. You'll see here that the Network Policy and Access Services installation succeeded with Routing and Remote Access Services. So I'm going to click on Close. Once I close out of that wizard, you will see here if I expand roles, Network Policy Access Services has been installed as a role. If I expand that, you'll see there's a subcomponent called Routing and Remote Access. Now there's a little red down arrow because we haven't configured Routing and Remote Access yet. We've just installed it. I could highlight this and configure it here, but rather than do it in the Server Manager utility, I'm going to close out of this utility. Click on Start, Administrative Tools, and you'll notice I now have an entry here for Routing and Remote Access. So I'm going to open up that utility, blow this up for you, and here you'll see that it needs to be configured. So I'm going to right click on the server itself and select to configure and enable Routing and Remote Access. This takes us into another little wizard. Click Next. Now there's a few choices that we're given here that are some typical scenarios that we might use these services for, but in this case we're not going to be following any of these scenarios. We will see some of these in later videos when we see about setting ourselves up as remote access servers. So I'm going to go ahead and click on Custom Configuration. If you want to be just a router, you select Custom Configuration. Click on Next. And then now I get to choose what services I want to enable. And I'm going to enable just the one service for LAN routing. And click on Next. And Finish. Now it'll take just a moment here, and it says I'm going to, it's been configured, need to start the service. So I'm going to click Start Service. And the remote access services, or I should say routing and remote access services, are started on this computer. Now it'll take just another quick moment there. There we go. You'll notice that the red down arrow has now become a green up arrow. And then we can expand our server to see there are more configuration options. So I'm going to click on Network Interfaces so that we can see our network interfaces on this router. Now the internal and the loop pack, I don't really want you to pay attention to those. Those are built in. They will always be there. The two that I want you to pay attention to are the ones that say Local Area Connection and Local Area Connection 2. Matter of fact, let's look at another screen which will show this in a little more detail. I'm going to expand IPv4 and then click on General. Here you'll see you have the same interfaces, but now over here we show the actual IP address affiliated with that connection. And without going any further, I will tell you this machine has been successfully set up as a router. There is nothing else that I have to do. I have a server that has two network connections. It has IP routing enabled, which basically means if any information comes in from one network on one network connection looking for a destination on the other network, it will send it, it will route it out the other network connection onto the other network. So as far as how do you set up Server 2008 as a router, well, that's it. We're done. But there is more information to take a look at. So let's look at some of that now. First of all, static routes. We're going to talk about static versus dynamic in just a few minutes. But the first thing I want to show you is I'm going to right click on this selection right here and go to Show IP Routing Table. The IP routing table is what tells this server what to do when it receives information. When this server receives a packet of information, it's going to look at the destination IP address and it's going to compare it against this table. And then depending on what this table says, that's what it's going to do with that packet. So over here we have our destination and network mask columns, and they work kind of together to determine, when you look at the IP address, you compare it against these destinations. We have a gateway column, which is telling us where to send the packet. Where, when I have something that meets a specific, like I'll highlight a line here, when I have something that meets this requirement right here, this destination, where am I going to send it to? And you'll see it's all zeros. I'll explain what that is in just a moment. And then we have the interface column, and let me expand that. Which interface am I going to, or which network card am I going to send the information out on? Local area connection or local area connection 2. Now after that we do have metric and protocol. Don't worry about those right now. I'll explain that in just a moment. Because what I want to do is I want to go ahead and close this. And I'm going to click on the Start menu to open up a command prompt. In the command prompt window, I'm going to type in route print. When you type route print and hit enter, this is the kind of the old way of doing it, but many people find this to be a lot easier to understand. So here's a command line version of that same routing table. Again, we have our destination and mask. We have a gateway. Now you'll notice instead of a bunch of zeros it says on link. Now what that means is it means I am connected to that network, or that destination is directly attainable by me. I don't have to go through another router. Over here, what interface are we going to go out on? Pretty much they're going to be either the 10.100 or the 11.100 network card, because those are the two cards I'm connected to. And then we have this metric column. Now, before I go any further, let me explain. Setting up a metric is for if you have a situation where there could be more than one way to get to a single destination. The metric will help the router to determine which way to try first. Whichever destination has the lower metric value, that's what it's going to try first. So if there are two directions to get to the same destination, maybe you have a scenario where you have a high-speed link and then a slower link, maybe as a backup. That would be an example where you would put the lower metric on the high-speed link, so it tries that link first, and only if that link is failing would you then go to the higher metric or slower link. Now the next thing I want to show you here is if I do a route /?, you will see there's a whole lot that I can do with this command, and I'm not going to go into all the detail, but what I am going to do is I'm going to use the route command to add a static entry to this table. So I'm going to type in route add, and then I have to give it a destination. So I'll type in the 192.168.15.0 network. I determined that that's the network by saying mask 255.255.255.0. Then I just hit space, and now I need to put in the gateway, meaning where am I going to send information that is destined for that network. So I'm going to put in 192.168.15.100. Now I will tell you that this is a completely fictional router. It does not exist on my network. Matter of fact, this network is completely fictional. I just want to enter this in so you can see it in the routing table. I'll hit enter. It tells me OK. What I'm going to do now is type route print again. Scroll back up a little bit. And you will see here that I have the 192.168.15 network with 222.55.0 network mask. In this case, instead of saying on link, see, I'm not actually connected to the 192.168.15 network. I'm not connected there at all. So I'm going to go ahead and say I need to send it to another router or another gateway, which is an IP address of 192.168.15.100. And then the system will determine which interface it's going to go out on. In this case, it's going to go out the 192.168.10.100 interface. And the reason why is because I'm going to type in ipconfig. You will see here that the 10 network has a default gateway configured on it, and the 11 network does not. And what that means is if I get an IP address that I don't know where it's supposed to go, I've never even heard of it, well, then I send it to my default gateway. just like any client would, any host would, really, I should say. So that's why, if I scroll back up here, it has determined that it's going to go out this interface, because this is the one that has a default gateway on it. So that's pretty much how the routing table looks and how it works. Now likewise, over here on the static routes, I could right click and select, let me go ahead and show the routing table again, and you'll notice that my 192.168.15 network has been added. Now I'm going to leave that on the screen, just move it out of the way a little bit. This time I'm going to right click and I'm going to select New Static Route. And this is where I can, through a GUI or a graphic user interface, enter the same static route just like I did through the command line. But there's a couple of little quirks that go along with doing it through the GUI. So let me show you. Under destination, I'm going to put in, this time I'll do the 16 network since we already did the 15 network. Give it a gateway of 16.100. Now this part's pretty much the same. Destination with a mask and a gateway. With the route print command, or I should say the route add command, that's all we had to do. Here we have the ability to manually select what interface we want to send this particular packet out and give it a metric. Now those options are available with the route add command, but are typically not necessary. So that's one of the little quirks about doing it through the GUI. So I'm going to go ahead and click OK. And here's the other little quirk. You'll notice that down here on my IP routing table, there is no entry for the 16 network. Matter of fact, if I close that table and I right click and show the IP routing table again, you'll notice it's still not there. And the reason it's not there is because it exists up here in the routing and remote access utility under static routes. That's the part that kind of throws people when doing this through the GUI. Matter of fact, if I were to click on start and go back to my command prompt and type another route print command and scroll back up, you'll see that it doesn't exist here either. So this is really what makes doing it through the GUI not as user-friendly. I know in most areas of the operating system, the GUI is a more friendly way of doing things, and the command prompt's a more manual way of doing things. But in this case, most routing administrators will prefer to use the command prompt. So let me go ahead and close this. And you know what? I'm going to actually delete this route. And as long as I'm deleting routes, let me go back to the command prompt. And watch this. I'm going to hit route delete. So I've told it to delete the 15 network. It tells me OK, route print, and it is gone. As you can see, it's pretty much just as easy from the command prompt as it is through the graphic user interface. Now, as I was saying before, there's not really much of anything that has to be done on a router, especially a Server 2008 router. There are other routing devices which have a lot more sophistication to it, but Server 2008, really, if you're going to use it as a router, it's typically used on an internal network for fairly basic routing purposes. But there is one other feature of this router that I want to show you, and that is I'm going to highlight General, click on that here, and then I'm going to select one of my connections, right click, and select Properties. The reason I'm doing that is because I want you to see these two buttons right here, inbound and outbound filters. This is the one thing that, if anything, would commonly be done with a Windows Server 2008 router, and that is setting up a filter. It's almost like setting up a real mild firewall. What you can do with these filters is you can control what traffic can come into the router and or can go out of this router based upon super basic IP configuration information. Let me show you how these filters work. I'm going to click on inbound filters. And by the way, please notice up here, this is the local area connection, or the 10 network, the 192.168.10 network. We have two choices when setting up filters. I know they're grayed out right now, and that's because we have no filters, but we'll see this in just a minute. We can either choose to receive everything. This is for an inbound filter. So anything coming into this router, we can receive everything and drop the exceptions. Or if we were to select the bottom one here, we could drop everything. So don't accept anything coming in on that network except for whatever we enter in below. So let me go ahead and add one of these filters and show you what we're talking about. I'm going to click on New. And again, we're doing an inbound filter, so we're looking for anything that's coming in from the .10 network. So for source network, I could enter anything ranging from a specific network to a specific IP address. In other words, I could say, hey, if somebody tries to come in from the 192.168.15 network, we can make that part of the filter. And then we would do that by putting in 222.55.0. That designates that entire network. Or I could say, how about if something's coming in from a specific IP address? So let's say that, all right, well, let's say this specific IP address, and the way we designate it as an IP address is by saying 192.168.15.243, and then put 255 in all 4 places for the subnet mask. That means this one computer, if that one computer was to send into this router, watch this, I'm going to click OK. It goes to any destination on any protocol. So basically, if this computer, right now, the way it's set up, if this one computer tried to send something into this router, it wouldn't go through because we're receiving everything except for this. Or I could click this button, and now this router will route nothing in off the 10 network unless it comes from this specific IP address. And you'll notice this IP address was not from the 10 network, it was from that 15 network. So we're saying anything, that one IP address coming from that one remote network, if it comes in here, we're going to allow it, or maybe that's the one we deny. But we can get more detail with this. Let me click on Edit. And this time we're going to say if something were to come in looking for, let's say, the 16 network. We'll do the whole network this time. Click OK. Now we're saying if this one IP address off the 15 network came in and was looking for any computer on the 16 network, we are not going to allow it. Or again, it could be the one that we do allow, depending on whether we receive everything or drop everything by default. Now the one more piece of detail we can go into here is click on Edit, and we can select a protocol. So let's say TCP port 80. Now what we're doing is we're saying if this one computer off the 15 network is looking for anybody on the 16 network via TCP port 80, which if you don't know is HTTP, or in other words looking for a web server, then we're going to go ahead and right now that would be the one packet that's dropped, or now that would be the one scenario that would be allowed. So that's pretty much how you set these up. There's not a whole lot of more sophistication to it. You say, hey, something coming from where, heading towards where, and you may set up a protocol, a specific port that they're using. Allow it or deny it based upon the concept of allowing everything and dropping the one thing, or dropping everything and allowing the one thing. So I'm going to go ahead and I'm going to delete that out of here. We don't want any filters on this particular router right now. I'm going to click OK. Now the outbound filter works the exact same way, other than the fact that now we're talking about data being transmitted out to this network. Okay, so you'll notice the window is exactly the same except for receive up here turned into transmit. Because now this window is exactly the same. The source network would be some other network with a destination of something that would go out on the .10 network. So it works the exact same way. So these inbound and outbound filters, which by the way, inbound and outbound sometimes are referred to as ingress and egress. Ingress meaning inbound, egress meaning outbound, in case you ever hear those terms. Those filters can be set up on the router. That's pretty much how you set up a router. Let's go talk a little bit about static versus dynamic routing. Static and dynamic routing are defined pretty much as you would expect them to be. In a static routing environment, all routers have to have their routing tables configured and updated manually. And we saw this just a moment ago in Server 2008. I showed you both through the command line and the GUI how to add a static routing entry. Now, adding one individual entry is not that big a deal, but if you end up in a large network with, let's say like 50 routers, every time you made one little change, you'd have to make that change on all 50 routers. I mean, imagine adding a 51st router with a 51st network. Now you have to go to each of the other 50 routers and add that routing entry manually. Not a whole lot of fun. So with a dynamic routing solution, routers can now communicate with each other and share their routing information with one another. Now, in a dynamic routing solution, each individual router is still going to know about the networks that it's attached to. So in the example that we just had in the Server 2008 router that we set up, that particular router was set up to, or I should say attached to the 10 network and the 11 network, and so its routing table automatically had that information. But as far as the addition of any other networks that are out there, this would all happen dynamically through the communication with other routers. Now, if you want to know how this really works, watch this. Alright, here's what I want you to do. I want you to imagine that you're in a classroom with me right now, and this really handsome looking dude you see down here? Yeah, that's me. And I'm going to give you a demonstration as to how dynamic routing works. So, it goes a little something like this. Hi, I'm a router. I'm attached to network A over here, and network B over here. I've been pre-configured with this information, but that's all I know right now. Now up here I'm also going to add an illustration for the routing table for the router. Right now the router knows about network A and B because it's connected. Hi there, I'm a router too. I not only know about network A, but on the other side of me I'm connected to network C. And again, here's a routing table for this router. Great, I'll keep that in mind if anyone over here is looking for network C. And then you'll see that this router has added an entry to its routing table which says that network C can be reached via network A, and it'll be one hop to one other router. And as long as we're sharing information, did you know that I'm also connected to network B? No, I didn't, but I'll make a note of it for future reference. And sure enough, this router has now added an entry into its routing table. Hello, I'm also a router. Not only am I connected to network B, but the other side of me is connected to networks D and E. Awesome! I'll keep that in mind in case anyone over here is ever looking for those networks. And as long as we're sharing information, I am also connected to network A. Good to know! And here's something really cool. On the other side of network A is another router. No way! Yes way, and that router is also connected to network C. Cool, I'll update my information. Hey you, the router on network A. I just found out about another router on network B. Yeah, so what? Well, that router is also connected to networks D and E. Just thought you might want to know. Hey, that is good information. Thanks. Now, all three routers are completely aware of all 5 networks. If you look at all 3 of these routing tables, you will see that all 3 of them have A, B, C, D, and E networks somewhere in the routing table. I also want to point out to you right here, here, and here, where you can see that instead of 1 hop, it illustrated 2 hops. Because as for instance, in order for this router over here to send something to network C, it's going to have to send it 2 hops to get to a router that knows about that particular network. And then the 3 little routers lived happily ever after. Yes, me, myself, and I. The end. Wasn't that just a really nice story about dynamic routing? Anyway, now that you know how dynamic routing works, let's talk about the protocols RIP and OSPF. First of all, RIP, which stands for the Routing Information Protocol. RIP uses a distance vector algorithm, which, what the heck is that? Well, that's a routing table. Just nice simple routing table, just as we've been speaking about all along. It's very easy to configure, easy to set up, but does not scale well to large networks. So RIP, real easy to use, easy to set up, got to keep it in a smaller environment. If you're going to move into a larger environment, then we move over to our other routing protocol called OSPF, or Open Shortest Path First. Now OSPF uses a link state algorithm, or sometimes just known as a link state table. Now the link state table is a table of links, just as it sounds, and the state of those links, up or down, whether the links are up or down. And in a very complex fashion, OSPF has the ability to, on the fly, calculate the best route at any given time. Now because of this, it is much more complex to configure and to set up, but it operates very efficiently in a large network. So, you know, each one has its pros and its cons. If you want to have something that's real easy to set up, easy to use, smaller environment, then you go with RIP. If you have a larger environment and you need to have that efficiency in that large environment, you go with OSPF. Windows Server 2008 no longer has support for the OSPF protocol. It only supports RIP, which kind of makes sense that Microsoft has done this because RIP was the only protocol that was really being used on Microsoft routers. Because Microsoft routers are generally used in more of a smaller internal type environment. So let's go ahead and take a look at how RIP works in Server 2008. Alright, for this demonstration, I am going to connect with New York Member 1. This was the Server 2008 computer, which we set up as a router in our last exercise. And what I want to do first is let's look at how it's configured. So I'm going to open up a command prompt, and in the command prompt window, type ipconfig. And this will show us our connections. Here we have local area connection on the 10 network and local area connection 2 on the 11 network. Now another thing that I want to do is type in route print, and this will show us our routing table. And you'll see here we have routing table entries for the 10 network and for the 11 network. So everything is set up as a router on this particular Windows Server 2008 computer. But in order to demonstrate RIP, we have to have another router to communicate. So let me close New York Member 1 for just a moment, and I'm going to open up New York Member 2. Now this is another Windows Server 2008 computer that I have already set up identically to New York Member 1 in the sense that I've already installed routing and remote access services. So again, I'm going to open up the command prompt, do an ipconfig, and you'll see here that local area connection is on the 10 network, just like New York Member 1. So both of these routers are connected to that network. And then local area connection 2 is connected to the 12 network. If I do a route print, you see here that we have entries on our routing table for the 10 network and for the 12 network. So everything is set up on both of these servers. Let me go ahead and close this, go back to New York Member 1. On New York Member 1, I'm going to go ahead and open up our routing and remote access utility. In the routing and remote access utility, under your server, under IP version 4, you'll find General. You want to right click on General and select New Routing Protocol. In here, you have the choice to install RIP. So I'm going to go ahead and click on OK. And there you go. RIP has now been installed. But unlike when we installed the routing services, there is a little bit more that needs to be done to configure this to work or to communicate with other routers. What you need to do first is to add an interface. In other words, I'm a router, I'm connected to the 10 network and I'm connected to the 11 network. Which, if not both of these networks, do I want to communicate with other routers? You can actually choose that. And you do that by adding the interface. So I'm going to right click on RIP and select New Interface. Now for this demonstration, I'm going to select Local Area Connection, which is our 10 network, because that's the one that's connected with the other router. So I'll click OK, and it takes you into the property sheet for this interface. At this point, there is really nothing that is typically done. I could just go ahead and click OK, and I'm on my way. But there are a few things that you may want to do. So I'm going to go ahead back into the properties of that interface. And right here, where you see Outgoing Packet Protocol. Outgoing Packet Protocol is where we can determine what protocol will be used to send out information. And the verbiage on it is a little confusing, but it's actually quite simple. We have the choice between RIP version 1 broadcast, RIP version 2 broadcast, RIP version 2 multicast, or everyone's favorite, the silent RIP. Now, RIP version 1 and 2 are really nothing more than older and newer versions of RIP. RIP technology originally was quite intrusive to a network and can still be intrusive to especially the large networks because it was all done with a broadcast technology, which created a lot of traffic on the network. So if you want to send out your information from this router to RIP version 1 routers only, then you select RIP version 1 broadcast. If you want to communicate with RIP version 2 routers only, Then you select RIP version 2 multicast. If you want to send out information to both RIP 1 and RIP 2 routers, then you, believe it or not, do a RIP version 2 broadcast. Again, the verbiage, I don't know why they couldn't have done this as simple as just saying, hey, communicate with RIP 1, RIP 2, or both. And of course, the last choice, silent RIP, means I don't share my information. I'm stingy. I may receive information, I may have my tables updated, but I won't share my information. So I'm going to go ahead and put this back to RIP version 2 broadcast to communicate with either a RIP version 1 or 2 router. It doesn't matter. Now the incoming packet protocol, this one they did put the correct verbiage in there, I think anyway, and that is to either ignore incoming packets, which means I'm not going to have my routing tables updated by another router. I'm not going to accept any other information, but maybe I'll share it on the outgoing side. I can select that I'm willing to take incoming information from RIP version 1 routers, RIP version 2 routers, or both RIP 1 and 2 routers. That's the easy way of looking at it. Now, the only other thing in here that you may actually do is right here on the Neighbors tab. The Neighbors tab is where you can help eliminate some of the broadcast traffic by specifying individual neighbors that you're going to go ahead and interact with. So you could go ahead and you could use broadcast or multicast only, which is how we're currently set up. You could use neighbors in addition to broadcast or multicast. Maybe there's a router, a distant router that you're aware of, and you want to be able to get its information, so you could add that router in here. Or you could choose to use, and this is probably the most typical if you're going to use this feature, use neighbors instead of broadcast or multicast. So if this particular router is in a location where you don't want to be creating a lot of broadcast traffic, then what you might want to do is just point to some other specific router by putting its IP address in here, and then that router may participate in broadcast and multicast over on its side, and it'll get updated information, and then it will share that information with you directly as in the form of a unicast as opposed to a broadcast or a multicast. And pretty much, like I said, I'm going to go ahead and put this back to broadcast or multicast only and click OK. That's it. I've been set up for RIP. Now you'll notice right here, responses sent and responses received, they're both sitting at 0. And they're going to stay at 0 until I have another router that I can communicate with. So let me go ahead and close out of this computer and open up New York Member 2. Now on New York Member 2, I am going to do the exact same thing. So I'm going to go back to Routing and Remote Access. I'm going to right-click on General, select New Routing Protocol. I'm going to select RIP. I'll click OK. Highlight RIP. Right-click and add the interface. Again, I'm going to do Local Area Connection because that's the 10 network. That's the one that is connected with the other router as well. Click OK. I'll leave all the defaults. Click OK. And again, what do we see? Responses sent, 0. Responses received, 0. Great. So I'm going to put that away. Let's go back to New York Member 1. Open up the Routing and Remote Access tool. And look what we have. We have 9 responses sent. No responses received yet. Let me see if I can refresh. Refresh a couple times here. No, nothing updating yet on the responses received. So let's go ahead and go back to New York Member 2. Go into Routing and Remote Access. Okay, here we see that responses are sent and received. So on this router, we should be able to now open up a command prompt, do a route print, and on this routing table, we have an entry for the 10 network, the 11 network, and the 12 network. And you'll notice this 11 network right here, 192.168.11, 222.55.0. Here you'll see there's a gateway of 192.168.10.100. Basically what this one's saying is out my 10.101 IP address, send it over to the router who's on 10.100, and that router will know how to route it over to the 11 network. So let's close out of this. We know everything's working on that side. Let's go back to New York Member 1. Let's do another refresh. Okay, now we have sent and received. So we have activity going both directions. Open up our command prompt, route print, and you will see here that just like the other, we have the 10 network, the 11 network, and now we have the addition of the 12 network, saying that if I need to get to the 12 network, go out my interface, which is 10.100, send it to the router at the IP address of 10.101, that's our other router, and that router will know how to route things onto the 12 network. And that's how RIP works in Server 2008. There's not a whole lot to it. You just need to install it, take most of the defaults, it all works, but keep in mind it can create a lot of traffic, so you want to keep this to some of your smaller internal networks. So, I don't know about you, but I think that routing is kind of fun. In this video, we learned what a router is, we looked at how to set up Server 2008 as a router, we saw the differences between static and dynamic routing. We talked about the two dynamic routing protocols and where each would be used. And although Server 2008 no longer has support for OSPF, it can be configured quite easily to use RIP in smaller networks. Well, that wraps up this video on routing. I look forward to seeing you in the next video.